Hello my dear students, welcome to our channel Mr. Physics, where physics gets charged. In the last videos we have discussed the concept of differentiation and the integration basic formulas, and how we are operating this differentiation and integration to the physical quantities. But most of the students will ask to me that sir, we are getting the fundamentals of differentiation and integration formulas very well, but we are get confused to how and when and where we are applying this differentiation and integration. Means for a given case, whether we are using the differentiation or integration, sir, will get confused. Then how we know that, sir? That question will be raised from the most of the students. Now in this today's video, I will give the clarification about this how and when we are using this differentiation and integration, right? So I am coming to the first, the basic thing is that when coming to the instantaneous velocity only is very well to us. So instantaneous velocity is equals to rate of change of position is nothing but a dx by dt. Means it is on differentiating the position with respect to time, we will get the velocity there. And now coming to the acceleration, whenever we are defining the acceleration is the rate of change of velocity with respect to time, which means a is equals to dv by dt. Means again, whenever you are having the velocity in the function of time, whenever you are having the velocity in the function of time, on differentiating the velocity with respect to time, you will get the acceleration. And here, whenever you have the position in terms of time, its position is varies according to time, so that on differentiating that position with respect to time, you will get the velocity. Otherwise, you may take one more. So the rate of change of momentum is the force, means F is equals to dp by dt. From Newton's second law of motion, we have F is equals to dp by dt, means the rate of change of momentum with respect to time is gives the force here. Means mathematically we can say that on differentiating the momentum with respect to time, which gives force. So now from this only I am coming to the reversely, that I have the velocity, sir, I have the velocity, and I am asking, they are asking the position. How we could find, sir? Got my point? Here I am having the velocity and they are asking the position. How we could find, sir? By using these three equations, is it possible? No, but because when you are having the velocity, you can find the acceleration by using differentiation. By having the position, you can find the velocity by using differentiation. But my question is, you have the velocity and you need to find the position. Does it possible? No, but it is possible. So by using this equation, see now v is equals to dx by dt. So can I write dx is equals to v dt? Dx is equals to v dt. Okay, mathematically just I am simply sending this side. So now on integrating both sides, when I am integrating on both sides to this above equation, what you can write here, integral dx is equals to integral v dt. Integral v dt. So that here can I write integral dx is what? Just now in the last video we discussed from basics of integration, integral dx is the x, integral v dt, which means now say if you have the velocity as a function of time and if you want to know the change in position of the body, on integrating the velocity with respect to time, you will get the position. On differentiating the position with respect to time, you will get the velocity. Or my point is, sir, we have the acceleration of a moving body and I want to find the velocity after certain time. How we could find, sir? You said whenever we are differentiating the velocity with respect to time, we will get the acceleration, fine. But when I am facing the question is that the body acceleration of the body is given, okay, and they are asked to find the velocity after certain time. So for that, again I am coming to here. Can I write dv is equals to a dt? Mathematically I am sending dt to this side. Then after I am integrating this on both sides. Integral dv is equals to integral a dt. Integral a dt. So that here integral dv is what? V integral a dt. Means by this I conclude that on differentiating the velocity with respect to time, we will get the acceleration. Again, on integrating the acceleration with respect to time, we will get the velocity. Now see, by using velocity we will get the acceleration, by using the velocity we will get the position. Whereas here by using the position, we'll get the velocity. By using the velocity, we'll get the acceleration. Means by observing these two examples, we can say that integration is the inverse phenomena of differentiation. The integration is inverse phenomena of differentiation. So the best is by differentiating the position, we will get the velocity. By integrating the velocity, we will get the position. Here also same. By differentiating the velocity, you will get the acceleration. On integrating the acceleration, you will get the velocity. Now coming to here, on differentiating the momentum with respect to time, we will get the force. So that can I write f dt integral is equals to integral dp. So that p is equals to integral f dt. Again it is the reverse. On differentiating the momentum with respect to time, we will get the velocity. On integrating the force with respect to time, we will get the momentum. Right? Otherwise, you may take one more example also. F into dx is the dw. The work done is nothing but the product of force and displacement. Means to displace through a small distance of dx, we need to do the work done, that is the dw, by applying the force F. Then how we could find the total work done to displace right from initial position to final position, sir? Simply on integral f dx is equals to integral dw, means w is equals to integral f dx. So that position is varies from its initial point to final point, so that we can write here xi to xf. This is what called definite integral we are discussing in the last video. So this is the way we can take the limits for a given function. We have to choose those limits of our own, depends on the situation or depends on the case. Here the work done on the body by this external force to displace it from its initial position to final position, or from its origin 0 to like 2 meters, depends on the case, please. This is the way we are using this definite integrals. Here also the change in velocity takes place from 0 to 2 seconds. And the velocity, if they are asking after certain time from 2 seconds to 4 seconds, these will become definite integrals. Now means there is no difference between a definite and indefinite integrals. Is only the difference is that we are choosing or we are getting the change in that function within a selected limits, like 0 to 2 or 2 to 4 or from initial position to final position. Otherwise, in the case of conservative forces, F is equals to, we can write the negative gradient of potential energy, means F is equal to minus du by dr, means on differentiating the potential energy with respect to position, you will get the force. At the same time, you can write du is equals to minus f dr. Again on integrating this, we will get the same. Integral du is the u is equals to minus integral f dr, means force is a function of position. When the force is a function of position, so that on integrating this force with respect to position, you will get the potential energy. So for all these examples, again when I am coming to the conclusion is this: integration is the inverse phenomena of differentiation. Even we can prove this by mathematically, right? See, I will give a small example to verify this, so that you will get very clarity about this differential integration. Okay, so d by dx of 3x square, suppose. So this is equals to 3 into x square, d by dx of x square we can write, so that, so x to the power of n dx is what? N into x to the power of n minus 1, means this is equals to 3 into 2 x to the power of 2 minus 1. So we got 3 to the 6x. 3 to the 6x, means on differentiating this 3x square, you got 6x na? So now I am integrating this 6x with respect to x only again, 6x dx. 6 is a constant, integral x dx. So this is equals to, we can write 6 integral x dx, nothing below there is power 1. So formula is what? Integral x to the power of n dx is x power n plus 1 by n plus 1, which means you can write x to the power of 1 plus 1 by 1 plus 1. So that what you will get here? 3x square. See, on differentiating the 3x square, you got 6x. On integrating the 6x, you will get 3x square. On differentiating the position with respect to time, you got the velocity. On integrating the velocity with respect to time, you will get the position. This is a mathematical and is a physical concept. Now here, on differentiating the velocity with respect to time, you got the acceleration. On integrating the acceleration with respect to time, you will get the velocity. But we are taking anyone, why? Because this is not restricted to this motion in a straight line only. This different basics of differentiation and integration is very useful in physics throughout the physics for 2 years, irrespective of the branch of mechanics or heat part, or you take electricity, okay, or modern physics, wherever you take, we are using this. Okay, otherwise I will give in a heat part one example. The specific heat is equals to 1 by m into dq by dt. Means on differentiating this heat energy with respect to temperature, of course the mass is constant there, will give us the specific heat. The same thing if you want to write in the integral form, so you can write dq is equals to ms dt. Means in the problem they are given the specific heat as a function of temperature, then they are asked how much heat it should be required, or acquiring or releasing. So for that I need to integrating here. When I am integrating this, integral dq is what, please? Q. So this is equals to, we can write a ms dt of integral. The temperature is maybe changes from 10 degrees to 20 degrees or 13 to 15, depends on the given. We are choosing the limits so that it will become again definite integrals. Means most of the part of the physics we are using definite integrals only, and those definite integrals means we are having some limits. That limits we have to choose according to our requirement in that case. That is what the difference between differentiation and integration here, right? So these are I am given the different various parts of the physics, just examples. So now in the next video I will derive the equations of motion by using this integration and differentiation. Thank you students, thank you for watching. If you like my videos, do like, share, comment and subscribe my channel to get more videos.